So there's various different aspects that we've had to look at because of this memory shortage at the moment. How long is it going to last? You know, that's the big $1 million question, if you like, at the moment. You know, people are saying it could last till the end of the year. Some people are saying another 18 months, 2 years. One thing's for sure, pricing and the allocation will come down, but who knows when.
Hi, I'm Shawn Luke from DigiKey. It's my pleasure to be here today with Randall from EDATEC, Dave from Raspberry Pi, Ryan from Gateworks, Bassel from NXP to discuss industrial single board computers. Thank you to all our guests for being here. Now let's talk technical. Hey, Randall, I want to ask you the question then. What is the difference between industrial single board computers and the consumer electronics that we're used to seeing?
So the industrial computer has things designed into it to prevent it from failing. There are some attributes like how much electromagnetic interference it can sustain, how much electrostatic discharge it can sustain. Does the system use opto-isolation or capacitive isolation? In the case of EDATEC, we use beyond the spec component selection. So whereas we have 24 volt IO, we use 80 volt rated components to sustain any kind of misapplication or noise. There's also power loss protection. So in our industrial PCs, you can order them with a supercapacitor backup solution so that you get 30 to 60 seconds, you detect that power going out, and you can gracefully shut down without contaminating memory or long-term non-volatile storage. The other thing we do is we have R&D stress testing. So we're putting devices through thermal cycling, hot to cold, vibration testing, extreme power cycle endurance testing. And then we also have 100% full unit testing. So those are some of the things that we consider. There's very little difference in the actual components used. A lot of the same design tools are used to design the integrated circuits. In fact, a lot of the same foundries. So those building blocks are pretty much the same. The difference is how they're combined into a system. And so in EDATEC's case, we're buying a well-proven compute module from Raspberry Pi, and we're adding the RS-232, RS-485, CAN bus, EtherCAT, multiple Ether, all digital input and analog, all of those extra I/O, and we're doing that with those attributes that I mentioned to make sure that we've got the anti-static, electromagnetic interference, beyond the spec components, and power loss protection.
Ryan, kind of curious where you see industrial single boards computers being used outside of the factory. Are there any non-factory applications that you're seeing industrial single board computers being used for?
Yeah, Shawn, absolutely. So, these rugged and industrial SBCs, they're being used across many other sectors. They're a very generic single board computer, and so they can go well beyond the factory. When I think of these single board computers, we're seeing a lot of applications where they're used as gateways and edge computing. And so like one of the big industries or sectors we're seeing would be in the smart energy sector. There's a lot of stuff revolving around grid monitoring to make sure our power plants and all the grid stays up. There's a lot of predictive maintenance using that SBC to, measure the temperature of a transformer. If it's getting too warm, they're going to send out a team to replace that before it fully blows. Even the utility line monitoring, you have these long power lines stretching, and sometimes the SBCs can be involved for checking those for any tree branches and whatnot. Solar's become a really big thing. The SBC can be a gateway in there, just getting readings from the solar and being able to control some of the systems with all the solar. You still got the oil and gas industry. We've had customers that do a HMI human machine interface where there's a touch screen and they can control some things out there in the oil field. Another big sector we're seeing is the transportation sector. So one of the big buzzwords lately is V2X, which is vehicle to everything, and that's trying to enable all our vehicles to be connected to basically help create safer roads, better traffic flow, even down to the parking level. And that does transmit over a special frequency, so it's mating the single board computer with the right radio to create a full V2X solution. And even also, you're getting into drones and UAVs. A drone can be a complicated system, but we have single board computers up there, sometimes even just being the network link within the larger system. We're moving on to rail. There's a lot of new stuff going in the rail industry for like collision avoidance, making our railways a lot safer, and even maintenance away stuff. Moving to the ocean, we got all the maritime stuff. A lot of ships out there transporting a lot, whether it's container tracking or even the vessel tracking itself. We've had computers deployed there, and then up in the sky, up in the aircraft, whether it's onboard Wi-Fi or even the media server in the plane for the seatback displays. We've been seeing that. And the last sector I'd bring up would be like smart cities. So we're seeing a lot of SBCs deployed for intelligent sensors across the city, just to monitor different things to help these municipalities take care of their city. Sometimes it's, gas readings, water meters, that kind of stuff. And it could even be as simple as like city Wi-Fi, just keeping everybody connected. So yeah, industrial SBCs are well beyond the factory and used in a lot of other sectors.
That's the perfect intro for Bassel. All right, Bassel, what type of workloads are you seeing out there? What's really pushing the hardware? Given that you guys are really focused on the compute end of things, what's pushing and driving that workload?
Yeah, well, I think Ryan mentioned that now industrial SBCs are not just focused on the factory or the industry. There's many different fields where you can find them. From there, I think they moved from being just simple controllers or just a simple gateway to execute more complex workloads and more advanced workloads. And we're seeing that a lot of them are data driven and latency sensitive. And so it pushes compute closer and closer to the machine. And some of the advanced workloads that we're seeing is vision system. We've seen this for the past years now. It's a big one where you need it for quality inspection, safety monitoring, process verification, and it's very great when you need a clear response and for example when you can't rely on the cloud basically and need to classify something in an image, for example. Predictive maintenance is also one that Ryan mentioned, and we've seen it in the past few years a lot as well. And especially since more and more sensors are being added to the equipments, and we see that more and more the customers they want to have actionable insights instead of just raw data coming out from their system. And one there is evolving, especially in the past few years, it has been Edge AI. With more complex models. And so we've seen them running in the cloud, basically. But more and more, we're seeing them coming up to the edge. And so they can do a lot of jobs in predictive maintenance as well, or vision systems, but they can go far beyond with large language models, for example, or vision language models, for example. And yeah, now we're seeing them being used at the edge and opening the doors to more use cases and applications.
So Bassel, are there any like constraints that you're seeing end up being the front runners? I don't know. Sometimes it becomes like bandwidth or IOs, or it becomes memory constraints and other things. When you talk about those big applications like Edge AI, what's the limiting factor at this point?
Yeah. Well, there can be a lot of limiting factors that we're seeing. One of them can be memory, for example, especially nowadays with the shortage of memory and RAM that we're seeing on the market. But yeah, I think in industrial systems, there's not just going to be like one bottleneck or one thing limiting, one thing that's going to limit you in your project. A lot of times we see that it's just multiple factors that come into place, and it's going to be power, for example. It's going to be thermal footprint, for example. Even cost can be part of it. Yeah, I think it's mostly going to be about balancing all those. And so, for example, for some of the intensive edge AI applications, the memory access tends to be stressed a lot because it's going to be data. You're going to have data moving from the CPU to accelerators and different peripherals. So the memory can be stressed. But we have also power, and power is going to be a lot of time in industrial environments. You're going to have power constraints, and you're going to have, because it's going to be, your device is going to be it's not going to be connected to a power supply, for example, or it's going to be a sealed and enclosed environment where you cannot have a fan, for example. So it's going to limit you in terms of heat and thermal footprint. And yeah, so given all those things, I think the biggest challenge for customers is being able to balance all those things, and making sure that they have the sustained performance, not always peak performance, but sustained performance for years of operation.
So there was an earlier mention about memory shortage. Dave, I wanted to send this over to you and ask you about how maybe sourcing patterns or things at Raspberry Pi have changed just due to the memory shortage.
Yeah, great question. It's what I'm familiar with every day at the moment. So just a very, very quick bit of background on this, which for anyone who doesn't know this, the cloud providers, hyperscalers, AI applications are really eating up a lot of high bandwidth memory at the moment. And that's really where the tier one suppliers in the memory market are going after. So that's caused the shortage. So what have we done? We're in quite a good position because of relationships that we've got, the amount of product and the relationships that we've built up over the last 14 years. But it's still very tough today. First thing is multi-sourcing. It's one key thing that everyone's got to do at the moment. It's making sure that you're not single sourced on your DRAM or on storage memory, your eMCC. Very rigorous testing that's been going on with these new suppliers, both here at Pi itself, with our contract manufacturer, which is Sony, also based in the UK, down in Wales. They do a lot of testing, and then we send the product out, the initial samples out to some lead customers. Then we'll PCN it, and then we'll bring in those second and multi-source vendors. Then there's a couple of like quite unique things. One of them is what internally we're calling clamshell, where we're putting two DRAMs onto a board instead of one. So if, for example, a 4 gig is really hard to get hold of at the moment, we can put two gigs onto a compute module, one on the top, one on the bottom, and make up a 4 gig. So the first product is already out in the market today, which is on a Pi 4, and that was announced a couple of weeks ago. The other thing that we're doing, we're talking to customers about right sizing their design. And what we mean by that is, for years, memory has been relatively low cost. And if someone could put down an 8 gig part or a 4 gig instead of a 2 that they might need, and they've continued to buy that product, we're asking them to look at it now. And if they don't need a 4 gig and they can get away with a 2, great. And we will help them do that. So there's various different aspects that we've had to look at because of this memory shortage at the moment. How long is it going to last? You know, that's the big $1 million question, if you like, at the moment. You know, people are saying it could last till the end of the year. Some people are saying another 18 months, 2 years. One thing's for sure, pricing and the allocation will come down, but who knows when.
Excellent. And I want to work off of something you had mentioned earlier, Randall. You were kind of talking previously about what makes industrial SBCs different than consumer electronics. And one of the terms that I've always heard is like ruggedized. So Ryan, I want to send this one over to you, thinking about the term of ruggedized, what makes an industrial single board computer ruggedized?
Yeah, so over here at Gateworks, we build rugged single board computers. One of the first things I would say that we're able to support is industrial temperature. So that means the board is rated from -40 up to 85 degrees Celsius. So that's a pretty wide range. That's covering the super cold for, say, a snowy Arctic environments, all the way up to the 85C, up in the hot desert environments. And so having a board that can handle that temperature swing is pretty critical for all these rugged environments. This has been touched on before, but having a board that has a really rugged power supply is really important. And I'm not talking about the power coming into the board, although that is important, but once the power is on the board, those power rails and whatnot, that's really important. So for a rugged SBC, you want to have a wide input voltage range. So the Gateworks supports 8 to 60 volts DC, which is a nice wide range to handle different transients and just handle a lot of different rugged applications. And furthermore, just the input range, you also want to have a lot of protection. So whether it's ESD strikes or burst and surge and various transients, we build the power supplies on the board to be able to handle a lot of these little power anomalies. Another big thing for rugged systems would be related to the mechanical part of it. So imagine all your cables being connected to the board. You don't just want these exposed vertical pins that can say vibrate loose or whatnot. So we're putting shrouded locking headers on the board, so that when you bring your cable assemblies in, they stay nice and secure. And so even also on the expansion slots, we use mini PCIe and M.2, and that allows a card to be firmly seated into the connector and then actually screwed down with screws. And you can even apply Loctite and whatnot to those screws to make sure that it's just really rugged for any vibrations kind of things. So another piece for a rugged computer, you just want something that's really high quality. If you're going into a rugged environment, you want a high quality board. So the Gateworks boards are made and supported in the USA. So it's a really high quality product with high quality components. Board's only going to be as good as the components you're using. So for example, like we're using ceramic capacitors instead of electrolytic. So those are just much tougher parts that are going to sustain the rugged environments. And along that component thing is also the supply chain. So it's important to get your parts from, reputable dealers. Unfortunately, in the electronics industry, there is a lot of gray market. To have a rugged product, you want to use authorized distributors to make sure you're getting the best parts, the real parts that have been qualified by the manufacturers. And last but not least, I would say would be the enclosure and mounting solution you're using for the single board computer. You can have any single board computer, but you want to put it in a nice heavy, solid enclosure. And you can really build that thing out and really protect the board. And even, the mounting inside of that enclosure can be critical. The standoffs you're using, all that kind of stuff can help matter for the vibration resistance and whatnot. So there's a lot that goes into building a rugged single board computer, and that's just a few of the items there.
That's excellent. And as you were going through this list, you're talking about the industrial temperatures, the wide inputs, the protections from ESD and power, locking headings, conformal coatings, enclosures, all these different pieces. One of the applications that I had bouncing around the back of my head is, in an earlier career, I worked for Target. I'd go into the food distribution centers, and the refrigerated portions, they would always be running at -40. So it doesn't matter, -40 centigrade, -40 Fahrenheit, it's the same number.
Yeah.
It's incredibly cold. I was just wondering if there was any particular applications or environments that you've seen that are really extreme like that you feel like really pushes your Gateworks offerings.
Yeah, so we've seen a lot of really rugged industries that are driving the more extreme environments. One of those would be like mining. You have all these really heavy tractors going over rocks out in the open exposed air, sometimes in the tundra, that kind of thing. So you're getting a lot of vibration, a lot of temperature exposure. And even factories, you think within a factory it's fine. Well, no, we're going into hazardous locations. So those are giving a lot of exposure. And again, the board should be well protected in an enclosure. But factories, you have, they can be wet, they can be loud, there can be a lot of vibration going on. And then obviously the defense sector, you can have a Humvee traveling through the desert going 90 miles an hour. You're going to have a lot of vibration there and temperature exposure. And moving into the skies like the UAVs, you're flying in the air, you're getting up into cold temperatures, you're having a lot of vibration from the plane moving around. And going even further up, you could have space deployments. We've actually had customers try to deploy these in space, and that's really testing the boards and needing some good conformal coating. And that's about, the sky's the limit right there. So we are seeing a lot of certain industries that are really driving that rugged deployment.
These are such critical systems. I feel like reliability, criticality just keeps coming up. Dave, are there any other additional words, or have we already beaten this horse dead about, ensuring reliability for these super critical devices?
From our point of view, reliability is like, it's non-negotiable. Quality, from the amount of product that we've shipped, you have to have good quality, and that it's having full control as far as we're concerned. And we have something called end-to-end engineering here at Raspberry Pi. The reliability comes from it's our own IP development, it's chip design, board design, industrial design, then the test and compliance that we do internally here with our own EMC chambers, for example. Software development is key, and Randall mentioned this earlier, and the upkeep, the continuous update by our own internal software team, making sure that everything is backward compatible for every one of our computers that we've ever sold. So all of these things put together makes the quality and the reliability second to none. And I just want to give you one case study, one customer that sort of backs this quality and reliability up. And it's not the biggest customer that we've got, but it's a really good example to show to customers who have thought that, Raspberry Pi is still for, enthusiasts or hobbyists. The example I'm going to give you is Sharp NEC or Sharp Displays. They've worked for a number of years with compute modules. And they designed a professional display solution for Heathrow Airport. So it's a flight information display system. And they had to go through very rigorous checks and reliability checks, because these are all the flight display information that you see at Heathrow Airport. So 3,500 flight displays throughout the airport. That was worked on by us with Sharp and with the team at Heathrow. So they've done a lot of checks, German quality with Japanese quality, to make sure that everything was tested for thousands of hours. These parts are going to be they're live now at Heathrow Airport. You cannot have the display system going down. The last thing you want when you're looking for when your flight's going to take off or when it's delayed is for a screen to go blank. So lots and lots of checks were done, the reliability, and they've given us some really good feedback on this about why they chose us, improved performance, the visual quality, it lowered their cost, open source operating system, low acquisition and running costs, long-term hardware availability and support. And it's all key things, and it's all about, reliability of the single board computer.
Dave, I want to throw a question over to you. I'm kind of thinking more that future perspective, in the reliability discussion that we just went through, we're talking about the longevity, the lifetime of these devices, how long they need to last. I'm thinking a little bit more along the development life cycle, that 3 to 5 year time frame. What do you think is going to change here in the competitive landscape for industrial single board computers?
So the big thing that I see at the moment is competitors. I think there's going to be a lot more competitors in the single board computer space over the next few years, and I think that's a really good thing for all of us. I think we're in a very good position at the moment because of what we've done over the last 14 years, and I think there's very few like for like competitors out there at the moment. On the downside of that, I still think there's an enormous amount of customers that don't really look at single board computers, or in our case, compute modules as such. And I think there's a massive opportunity, and I think that really will grow over the next few years, where typical OEM customers, end customers, the majority of people are still doing designs with discrete components. And there's a lot of challenges for them, from sourcing, purchasing, their accounts, inventory holding, shortages, approvals that they need to do, compliance. And I still think there's some reluctance from some engineers to look at single board computers. And it will be a big advantage for them. And I think everyone that we've been talking about on this on these questions today and about the applications, there's more and more applications that single board computers are going into today. Many customers that start designing with compute modules or single board computers come back to you again and again, because it is a great solution for them. Number one, time to market. It is so much quicker. It can knock off at least 6 months in many cases off of their design cycle. Moving to a single board computer or a compute module. We sell a single board compute module from as low as $15, up to over $300 today. But there's many options, and they're tried and tested. It's a proven platform. We have sold over 73 million computers over the last 14 years. So very, very proven platform, and it is continuing to grow. And I truly believe that over the next few years, it's really going to explode. So multiple options, customers can buy what they need, and it's time to market. And I truly believe that the biggest thing will be more competitors coming into this space, more competition. But I think all of us around here are very well positioned for this. And the more customers, that start looking at it, will just drive this, and they won't go back to designing up from board level using discrete components.
Greatly appreciate that. Hey, we'll put additional links in the description from our guests. Use the comments section below to tell us your thoughts. Thank you to all our guests for being here today. Like and subscribe. See you soon.